Hello everyone. Today I'm going to be walking you through a climate indicator in relationship to the ocean. The specific climate indicator I'd like to talk about is coastal flooding. So I created a PowerPoint to kind of walk you through it. I'm just going to share my screen. Okay, start from the beginning. Oh, okay, so the ocean as an indicator of climate change. The ocean has an interactive relationship with the climate, and what I mean by that is that the ocean impacts the climate and the climate impacts the ocean in sort of a feedback loop kind of way. Some examples of this are that the ocean influences weather on a global scale. It is able to do that because as the ocean water heats up with climate change, it evaporates a lot of that water, and that water goes into the atmosphere, creating more drastic weather events like hurricanes more frequently and things like that. The ocean also absorbs heat that would otherwise be in the atmosphere. It absorbs actually 90% of the heat that's emitted by the sun that would otherwise be in the atmosphere if the ocean wasn't there, which is great for us as a society because we're not feeling the impact of that aggressive temperature change, but it has a lot of negative impacts on the ocean as well. The ocean is also a carbon suck from the atmosphere, which is, again, kind of great because it keeps a lot of the carbon, which is a known greenhouse gas, from being in the atmosphere and causing like faster change. However, this does lead to ocean acidification, which has all of its own complications, including a negative impact on the shells of sea critters as well as coral reefs. The last thing I want to note about this is that the ocean is rising. This is due to a lot of different things, including glaciers melting, as well as the ocean water itself is expanding because it's getting warmer. This leads me to our next topic, which is the thing I'd like to focus on, which is coastal flooding as a climate change indicator. So coastal flooding measures flooding along the coast using tidal gauges. This is important because the gauges measure continuous water levels, which allows us to have the measurements of tidal heights, long-term relative local sea rise, and coastal floods. The limitations to the coastal flooding indicator are that the flood threshold varies based on the location, so it should only be compared on a city-by-city basis on the trends and not the exact numbers. This is because different cities have a different like maximum tidal height before flooding. So for some people, there might be 10 inches might indicate a small flood, and other places 30 inches might indicate a small flood, simply based on what barriers they have set up and things like that. This information is also limited to only where the gauges are located, and they are clustered along the East Coast, so the information is limited on the West Coast. Okay, so I want to talk about these graphics. I'm going to zoom in a little bit here so you can kind of get a better look. So this is what I was talking about before when I was saying that you have to look at the trends of all of the cities and not the raw numbers from the cities themselves in order to get a good understanding of how the coasts are flooding consistently. And so the big thing that we're comparing is the time. So we're comparing from like the 1950 to 1969 to the 2010-2015 range because we want to see what kind of impacts that humans have had on climate change, being that we know that's from like the industrial period picks up there. So as you can see, the trend is pretty consistent that compared to the 1950s, floods are astronomically higher now. And that's kind of across the board there. Okay, and so specifically, this graph shows the number of days per year in which the coastal waters rose above the local threshold for minor flooding. So this is at 27 different sites along the US coast, and they've been averaged out per year. Okay, so then, oh, alrighty, so this shows a similar perspective, but it shows really clearly the 1950s compared to the 2010s, and it also has a few more cities listed here. I'm just going to move this. So as you can see, the orange bar compared to this purple bar, it's very clear that there are far more frequent floods now than there were in the 1950s. So this map shows the average number of days per year in which coastal waters rose above the local threshold for minor flooding at 27 sites along the U.S. cities. So I apologize, I think the same number of cities. But it is clear that we've had a massive impact. Okay, so this is from, everything so far was from the EPA source, that the EPA website about climate indicators. This source I found here at the Climate Central website. And I thought this was really interesting because it showed the difference between natural caused and human caused coastal flood days. So it just kind of solidifies that other perspective that we had a massive impact on coastal flooding based on our carbon emissions and other climate change indicators. I want to go back just a little bit here, and I wanted to focus on North Carolina, because the big thing with understanding an indicator is understanding that it affects different communities, and I wanted to talk about North Carolina a little bit. So with this massive increase in floods, coastal cities could very easily be aggressively impacted between their streets flooding and businesses having to shut down and infrastructure issues. It's really clear that this is a massive problem. Okay, so I just want to thank you for your time, and I am going to end the video here. Thank you.